So in the last video, we covered policies, users, and the profile flag. And we showed how when you create a user, you essentially generate API keys for that user. You then configure those API keys locally, and then you can use the profile flag to point to or essentially reference those local API keys. So when you make an AWS CLI command using that profile flag, then the CLI API will know what credentials to use, and so it'll essentially be authenticated and authorized, and or authenticated and be able to access whatever resources that user is authorized to access. That being said, you can still feel like you don't fully understand the CLI, and that's understandable because there are still some parts that might appear like they just work and you don't know exactly the mechanisms by which they work. So when we ran those Glacier commands in the last video, list vaults, that kind of stuff, how does the data get returned? What does that traffic look like? How does your CLI tool actually communicate with the cloud and actually get data back? And so that's what we're going to dive into this video. This is a bit more in the weeds. If you're fine with the AWS CLI so far and you have a good handle on it and you don't want to learn any more about it in depth, then you can probably hop to the next video, which is about roles. And once we understand roles, you'll pretty much understand most of the IAM concepts I'm trying to communicate in this video. But for those of you who want to understand what that traffic looks like and get a bit more in the weeds, that's what this video is going to cover. So it really comes down to that when you make an AWS CLI command, so when we make a list vaults API call or S3 LS call like in that screenshot below, what's really happening is your CLI is creating and sending an HTTP request in the background to AWS. I'm going to assume you probably have a good understanding or at least know what HTTP requests are. Those are just requests of like when you're clicking buttons on a website, when you're navigating to new URLs, HTTP requests are being sent from your browser to a server. In this case, the AWS CLI command is going to create an HTTP request and then send it to AWS. And so that's what the traffic basically looks like. You make an AWS CLI command, the HTTP request goes out, an HTTP response is returned, and the data from that HTTP response is displayed in your terminal. To see that traffic, we're going to set up a local intercepting proxy using a tool called Burp Suite. And so what we're going to do is we're going to run our CLI commands and direct the HTTP traffic to the local instance or to the local application that is Burp Suite. And so we're intercepting that HTTP request before it gets sent to the AWS cloud. And then we're going to be able to see what the HTTP response looks like. And then we're going to see that populates our terminal. So Burp Suite just lets you essentially see the traffic before it leaves your computer and the response that AWS will give you when it comes back to your computer. In order to intercept in Burp Suite, I'm going to show this all in the interactive portion, but just run through the slides first real quick. In order to intercept this in Burp Suite, you can set up environment variables like I did in the screenshot below, specifically HTTP underscore proxy and HTTPS underscore proxy. And when you set those up, those are going to direct the traffic to that proxy instance. So in this case, Burp Suite runs on port 8080. So I'm setting those two environment variables. And so when I go to make CLI commands, it's going to construct the HTTP request and then look at those environment variables and send the HTTP request to localhost port 8080 first, which is where I have Burp Suite running, and then we can intercept it in Burp Suite like in this picture below here. And then you can forward it along to the AWS cloud, and then the HTTP response will be returned. So we forward that request. And then again, you still have the proxy up, so then the response comes from the AWS endpoint here. And you can see that in the response, in this example I have in the slides, it returns test bucket. And if we look at our actual terminal, you'll see that test bucket is returned. So this is what happens. You make this command. So we make this CLI API call. It sends out this HTTP request. You then get an HTTP response from the AWS endpoint, and the data from that HTTP response is what pops up in your terminal. So it's all really just HTTP traffic in the background. One thing you notice though is in that HTTP request, we had kind of a unique authorization header here. AWS S4 or AWS 4, HMAC, SHA-256, credential, all this stuff. And so when you're sending out HTTP requests with credentials in AWS, they have their own unique special way to sign those HTTP requests, and it's called signature version 4 or SigV4 basically. And SigV4 is how AWS actually signs the HTTP requests that go out. I'm going to show some documentation here in a second about what that is, because the formula in which they construct this SigV4 signature is in the public domain. There's like tons of articles about how to compute this and all the different programming languages, which I'll show, but kind of summarize and not get too far into the weeds here. Essentially, this signature is derived from your credentials combined with API keys, or I should say it's composed of your API keys and HTTP headers, and I think sometimes the URL path, and it takes kind of all these elements of the HTTP request and then does a bunch of hashing and stuff and spits out this signature. So again, let's jump over and look at what that documentation actually looks like, but you don't really need to know exactly how the formula occurs. You just need to know that it takes a bunch of different elements and kind of hashes them together, and those elements include your API keys and some of these headers. And you can actually see in the signature, see how it says signed headers equals host and then all these other ones. So those are some of the headers it's grabbing. So when it computes the signature, it does your API keys and then whatever these signed headers are. So that includes the host header here, it looks like, and X Amazon content, SHA-256, and then X Amazon date. And so the problem we're going to run into, and the one I'm going to show, is if you want to modify this HTTP request directly, then if you change one of these signed headers or you change the URL in any way, you're going to get a 400 error response because the signature is not going to be correct. And because the signature involves hashing and stuff, it's not trivial to compute this kind of on the fly as you're editing stuff. And so we're going to go over a plugin that helps us do that. Let's jump to the web browser documentation. So like I mentioned, SigV4 is a very well-known, well-documented method of authenticating requests. And so if you just Google SigV4 AWS, then this link pops up, the first one, authenticating requests. If you open that one and you scroll through, it gives you some descriptions, it gives you kind of like a high-level overview, and then authenticating requests using the authorization header. If I open that link, then I get this page, and if you read through it, they break out each portion of the authorization header. So you have this AWS 4 HMAC SHA-256, and then you have, let me zoom in a bit, there we go. And then you have your credentials part, which is your access key here, the date, the region, the service, and AWS 4 request. Then you have signed headers, so what headers are you actually signing in the HTTP request, or what headers are basically going into this signature. And then you have your signature at the end, which again incorporates your API keys and headers and the URLs and a bunch of stuff, basically all factors into that signature. And they break it out here. And in terms of like, well, how do I calculate that signature? Like I mentioned, they explain how they calculate the signature. So like normally you don't have to worry about this because the AWS CLI does all this for you in the background when you issue those API commands. But we want to know like how we can possibly change the HTTP traffic, or what is exactly happening in the HTTP traffic. So if you actually want to create this signature yourself, so not rely on the CLI to do it automatically, but maybe write a script or a programming language to do it, there's another documentation page that's called Create a Signed AWS API Request. And if you read through this, you'll see they walk you through exactly how they calculate this signature. So here's like the canonical request, and then they get some hashes, and they put a bunch of stuff together, and then you can see they start hashing stuff. So your API keys. So you concatenate AWS4 and the secret access key, and then call the hash function. As you can see, they go through and hash a bunch of stuff, and then at the end, they basically compute this signature. So again, this is all like the the way to calculate SigV4 is not a secret, I guess is what I'm trying to emphasize. Like if we scroll to the bottom here, you can see a bunch of different people and a bunch of different programming languages have wrote little snippets to calculate that signature portion here in SigV4. Not that one. The signature portion here in SigV4. And so like Bodo 3 is like one we were looking at before in Python. So you can take a look at this and you could like read through all this code and understand exactly how it's creating the SigV4 and all that stuff. But there's another documentation page that maybe is a bit simpler called Using Signature version 4 with Amazon Translate. So that's actually a service, but this also is a page that goes through how you create the signature. So for example, they give you like an example, it looks like, for Translate, the Translate API specifically. Create the canonical request, calculate the string. So I know there's this snippet and it will calculate it for you, and it seems a bit simpler than kind of the big Bodo 3 library, but the point is like the code's out there and you can calculate signatures if you would like, writing your own Python scripts and stuff. As we'll see when we do the interactive demo, that would be really cumbersome if you wanted to change the HTTP request, you had to like write a big script like this and calculate the signature each time. So there are plugins that exist for Burp Suite that will basically do all of this for you in the background so you don't have to worry about it. And that's what we'll show. But again, just emphasizing, if you did want to script this out and use a scripting language or any type of programming language and manually compute that SigV4, then there are code repositories with that code, and then there are some AWS documentation pages with also some code snippets. Okay, but now we run into a problem. Because the signature is computed using the URL and host and headers and your API keys, if you change some element of the request, maybe you want to replay the request in Postman or you want to replay it in Burp Suite Repeater, then you're going to get something like this, some response that says signature does not match. Because if you change some component of the HTTP request, then the original signature that was computed no longer aligns with what the actual signature should be. And like I said, and like we saw through the code, it's not super trivial to compute that signature just by looking at the HTTP request. So you can use a Burp Suite extension, which will show in the interactive portion, and you can add this Burp Suite extension, put in your API credentials, and then you go ahead and enable it, and it will automatically compute the signature for the HTTP request as you change stuff in the request. You basically don't have to worry about the signature anymore because this Burp extension is computing it in the background. The one I'm showing here is the AWS signer. This is actually created by the company that I work for, so that would be NetSpy, like I mentioned in my first video. And again, you just load in the creds. You don't have to worry about the authorization header anymore. And so once I load in that Burp extension, I can change some stuff about the request. So like I added /test. That's not really going to give me a whole lot back because the test bucket doesn't exist. But the Burp extension is changing this signature in the background so that it aligns with the other stuff I've changed. And then just a tip is you're not going to see this change in the repeater tab itself. And I'll show this in the demo. You need to go to the logger tab and you'll actually see the modified request. Okay, and so with that pretty much concludes SigV4. And now let's jump into an interactive portion so I can show you what that looks like in Burp Suite. Before we jump to Kali Linux, I just want to show that for the user we're going to be working with, I went ahead and just added read-only access again for Lambda. So we're going to be working with the get functions Lambda API call, and so this is why you're able to make the API call because I added these permissions for this example. So I'm working out of Kali Linux, and so Kali comes with Burp Suite automatically, so that's what I've opened here. If you search for Burp, it should pop up here. This is the Community Edition. Depending on what OS you're on, if you're on Windows or something, you can still get Burp Suite. You just download it from the Portswigger site. I'll include a link of that in the description for this video. But at this point, I have my Burp Suite set up, and the intercept is turned on. So we're going to go ahead and make the get functions CLI API request that's part of the Lambda service, and we're going to intercept it in Burp and see what that request looks like. So this is the API call, remember, to get the function. We're working out of the US East 1 region, and we are grabbing a function that we made in like our very first video called presentation function, and it's the get function API call. So if I call get function, it returns a bunch of stuff, but notice it did not actually pop up in our Burp Suite. The reason is because we need to tell the CLI to send the HTTP request it's constructing to Burp. Because remember, what's happening is I run the CLI command, the CLI in the background creates an API request or creates an HTTP request using the API credentials and some other stuff. It then sends that HTTP request to an endpoint in the cloud. An HTTP response is then returned, and then the content from that HTTP response is displayed in your terminal. So when we sent this, we didn't get anything in Burp because we have to tell the CLI by setting that environment variable to send the HTTP request that it constructs in the background to Burp Suite first, or our local proxy, and then we can forward that to the server. So in order to do that, we have to set two flags, and you can see I've already done this before. So export HTTP proxy, and then export HTTPS proxy. And now, if I make the exact same command, but I leave intercept on, and I run this, we'll get a delay, and then we'll get an error back saying that the certificate failed. And this is because we're like proxying through Burp, and it doesn't really like the certificate stuff. So you can add another flag called no verify SSL, I believe, and then you run this, and immediately Burp will proxy that traffic. So you can see that in the GET request, this is what so we haven't got a response yet in our terminal, right? And that's because we're intercepting the request it created and sent out, and so it's sitting in our Burp Suite instance here on our local host. So it's going to go to this host header, and I'm going to forward this request and intercept the response, and then let the response go through, and the response is what's going to pop up in our terminal. But there's a couple things you can note from this request. One, this is the endpoint it's going to, so that's where the request is going. And then we have our SigV4. So these are our access keys, right? If I look at my credentials, HF7, and this ends in HF7. This is the region, Lambda service, and then these are the headers that go into computing that final signature. And then you can see that the CLI in the background computed the signature for us and then added it to the HTTP request. So if I go ahead and intercept the response, if I forward this request to this endpoint, it might have tried multiple times because it didn't get a response. So let me start from the top here. So I might have waited too long. So if I send that, and I'm going to intercept the response, so I forward it to the server, yep, and a few seconds later I get the response from the server. So again, the request went to the server, and then it came back to my host, and I'm intercepting that response before it reaches my terminal. If I forward this response, it pops up in my terminal. So again, like the command is sending out an HTTP request, and what you're seeing in your terminal is the HTTP response. It's just in a textual format here. Looking at the request we sent out in our logger tab, so this just shows our history of stuff, you can see, like I mentioned, you've got your signature and then your host header and all that stuff. And then all this stuff in the response is the thing that was displayed in the terminal, but what if you want to edit this request? So what if you don't want to call the API through the CLI? Maybe you just want to edit it in, it doesn't have to be Burp Suite, but I'm going to send it to Repeater, or you could use maybe a tool like Postman. You just want to send this HTTP request as a standalone, but you want to edit some parts of the HTTP request so that you can see how the behavior differs, or maybe you just want to look at what that, analyze what that traffic looks like. So because this signed header includes some of these, or because this signature includes some of these signed headers and usually part of the URL, if I try to change any of this and send it, then I'm going to get a bad response. So for example, it's signing the host header, or maybe it's signing X Amazon date. So if I change X Amazon date to testing 1, 2, 3, 4, or actually if I send this request as of now, it'll work. If I change X Amazon date to test 1, 2, 3, 4, and something else to note real quick is these signatures usually have some type of time limit, so I can replay the request right now, but actually let's keep this as is, and I'm going to make this exact same request, send request. I'm going to make this exact same request in, I don't know, like 30-ish minutes or something like that, and I'm going to show you that this signature basically will expire. And that's why you need to compute it every time, because it, like, the date factors in. But if I change X Amazon date to test 1, 2, 3, 4, and I send that, it's going to give me an error because that's in the wrong format. So let's try just change. So instead of 2023, I'm going to do 2021. Signature expired. Not picking the best examples here. So that's complaining the signature is expired. And you can see here it's saying it looks like, I think, maybe 5 minutes, but maybe if I change something in the path here. So if I change the name of the Lambda function from presentation function to presentation function test, and I send that, here we go. This is what you're going to see. Something like the request signature. So this signature does not match the signature you provided. So this is the signature I provided, and then they're basically saying the signature you provided doesn't match what the signature should be. And so if we're trying to work with requests, because we're working with GET requests right now, but if you're trying to work with any type of request using the SigV4, then you might run into this problem because you want to edit portions of the request, but you'll just get this invalid signature exception response. So, I mean, you could take all these components, write a Python script, and compute the signature again, but we already have an extension that does that in Burp. So if you go into extensions, go into the BApp store, and you go to AWS Signer. Yep, if you go to AWS Signer and you just one-click install that. Okay, it's installed. A new tab will open up here where, remember how we used profiles from the command line? It's a similar concept here. We can add profiles with our different creds. So I'm going to go ahead and do region is US East. We don't actually, I think, have to fill out this stuff. So see how it says optional? So I'll just jump into the access key stuff. So these are our API keys. Remember, access key, secret access key, and session token. So I'm going to go into my credentials. I'm going to grab the access key ID and the AWS secret access key. I'm going to put that in. See, there's a helpful test profile credentials. If I click that, it says success. So this is telling me that these API creds actually worked in terms of like API calls. So if I put in, like, instead of F7, if I did F7.6 or the wrong access key and I test that, I have to click out of it. If I test that, it's going to get an error. So this is just a really nice sanity check to make sure that, yes, the creds I copy and pasted in are correct. But you can add more profiles and give them different names and stuff. And we're going to say signing enabled, and we're going to go back to our repeater tab. So remember, this will fail. At this point, the signature is expired. So remember, if I send this request that worked, if I send it again, signature expired, and this is what I was talking about. Your signature will just naturally expire. So it's not like you can replay a request from yesterday, for example. You have to just keep computing these signatures each time. So if I right click here and I go into extensions and go to AWS Signer and go to, so enabled signing, so signing is enabled, and I have to choose what specific profile I want to sign with. If I send this exact same HTTP request, notice I still get an error because presentation function test doesn't exist. So I get a basically like a 404 resource not found exception, but I don't get an invalid signature exception. So my signature was actually valid. And you'll notice that the signature didn't change here, and this is what I was talking about. You won't see the change signature here. You have to go into the logger tab and look at the request you just sent, and you will see the change signature. So like this signature starts with 3 sevens, and our signature starts with 979. So the actual request that got sent, you just need to look in the logger tab, but you'll see it actually changed our signature based off how we changed the rest of the request. And so basically by setting up AWS Signer in this way, you can edit this request without having to worry about computing the signature, and this plugin will compute the signature for you in the background. And that pretty much covers SigV4 and how you can install this plugin to edit requests directly. Notice I've just been talking about users this whole time. Like the exact same thing is applicable for roles. So we'll see in the next video, once we discuss roles, there's an extra API token return called session token, and you would just paste that into here and it would work the exact same way. You would paste it into here, you would enable the profile, and then you can just repeatedly send requests here while editing the content, and it will sign it for you, and you can see the actual signature not in the repeater tab. You just have to check the logger tab and you'll see it pop up. So that pretty much summarizes this section for SigV4. To cover the broad concepts here, we have SigV4. It's an authorization header specific to these AWS API calls. As I showed at the beginning, there's plenty of documentation about what it is and how they actually compute the signature. All these different programming languages have little snippets of how to compute the signature. In terms of how the CLI works, you send a CLI, or you make a CLI command, it makes the HTTP request in the background, it sends off that HTTP request to the server. That HTTP request includes a signature, which in turn incorporates your API credentials and some other stuff. The HTTP response is returned to your computer, and that HTTP response is then shown in the terminal. If you want to edit the HTTP request as a standalone, you can use this handy AWS Signer plugin, and then you'll be able to repeat it in, or edit it in your repeater tab. And this is just for Burp Suite. I'm not going to show Postman, but I think Postman has a similar thing where like a lot of these tools where you send the API request have a way for you to just compute this signature in the background, so you don't really have to worry about it and you can just focus on the rest of the request components. Notice that I didn't need to specify region, service, or key ID. You can always put those in if you want. And you can also specify if you only want to do in-scope stuff. So, and again, you can add multiple profiles. So like maybe if I have another profile, user profile, and these are static credentials, so just user credentials, or user or role, they're just static creds. And so instead of doing these API creds, I could like plug in these API creds for one of the other users I made earlier. And then if you want to send requests as that user, you just change the profile and you'll see the new profile pops up here. You just click that and now you're sending the request as that other user. So with that, I'll end this video and we will jump into roles next.